Welcome everyone to the What Happens When channel, where everyday questions are answered. Before we get into it, why don't you hit the subscribe, like, and smash the notification bell? Okay, let's do this. Black holes have captivated human imagination for generations, representing the most enigmatic and powerful phenomena in our universe. Today, we're embarking on a journey to explore what actually happens when you venture into these cosmic behemoths. And the truth is even more fascinating than fiction. Picture yourself at the controls of an advanced spacecraft, approaching the outer reaches of a supermassive black hole. As you draw closer, the very fabric of space begins to warp around you. The massive gravitational force ahead creates an optical illusion, bending light itself and causing the stars behind the black hole to appear as a twisted ring of light, an effect known as gravitational lensing. This is your first hint that the normal rules of physics are about to be dramatically altered. As your ship crosses the point of no return, known as the event horizon, you've entered a realm from which nothing, not even light itself, can escape. This boundary marks the beginning of an extraordinary transformation. The immense gravitational forces begin to affect your spacecraft and your body in ways that challenge our understanding of physics. The difference in gravitational pull between your head and your feet becomes so extreme that you experience a process scientists call spaghettification. Your body literally begins to stretch, being pulled apart like cosmic pasta in a process that demonstrates the raw power of gravitational forces. Time itself begins to behave differently as you descend deeper into the black hole. Einstein's theory of relativity predicts that time slows down significantly in strong gravitational fields, an effect known as gravitational time dilation. From your perspective inside the black hole, time might seem to flow normally. But if you could somehow look back at the universe outside, you would see everything moving at an accelerated pace, as if someone had pressed fast forward on the cosmos. The journey deeper into the black hole reveals even more profound mysteries. The laws of physics, as we know them, begin to break down entirely. Quantum mechanics and gravity, two fundamental forces that scientists have struggled to reconcile, clash in ways we can barely comprehend. The space around you becomes increasingly curved and distorted, leading to what physicists call quantum fluctuations, tiny variations in the fabric of space-time itself. What makes this journey particularly fascinating is how it challenges our understanding of group dynamics in extreme conditions. If a team of astronauts were to enter a black hole together, each member would experience these phenomena slightly differently. The precise way gravity affects each person depends on their exact position and orientation, making every journey uniquely personal, even within a group setting. This creates an interesting parallel with human experience. Though we may travel together, our individual perspectives remain distinct. As you continue your descent, you encounter what scientists believe to be the singularity, a point where the density of matter becomes infinite, and the known laws of physics cease to function. This represents the ultimate boundary of our current scientific understanding. The mathematics we use to describe the universe simply breaks down at this point, suggesting there's still much to learn about the fundamental nature of reality. The concept of time becomes increasingly meaningless as you approach the singularity. Some theories suggest that space and time might become so warped that you could potentially see multiple versions of yourself, or glimpse events from different time periods simultaneously. This mind-bending possibility arises from the extreme curvature of space-time near the singularity. What's particularly intriguing about black holes is how they challenge our notions of conformity and individuality. In normal space, objects and energy behave in predictable ways, following well-established physical laws. But inside a black hole, these rules begin to break down. Each particle, each wave of energy, each piece of matter follows its own unique trajectory, defying our expectations of how the universe should behave. The journey into a black hole also raises profound questions about the nature of information and its preservation in the universe. According to quantum mechanics, information cannot be destroyed, yet black holes seem to erase everything that falls into them. This apparent contradiction, known as the black hole information paradox, continues to puzzle scientists and philosophers alike. As we conclude our theoretical journey into a black hole, we're left with more questions than answers. These cosmic giants serve as nature's laboratories, testing the limits of our physical theories and challenging our understanding of reality itself. They remind us that the universe is far stranger and more wonderful than we could have imagined, and that there's still so much left to discover beyond the boundaries of known physics. The next time you look up at the night sky, remember that somewhere out there, these mysterious objects are continuing their eternal dance, bending space and time, challenging our theories and waiting to reveal their secrets to future generations of explorers and scientists. In the end, black holes represent not just the ultimate physical boundary in our universe, but also the boundary of human knowledge itself, forever pushing us to explore, question, and imagine what lies beyond. Thanks for watching.